Welcome everyone. This will be our last interim for this season. This is a reminder that not well applies here. Logistics, again, please add your name to the list. I just posted that link to the chat, so I see about 15 people. Please go ahead and add your name. And if you wanna speak up, please go to add yourself to the queue by typing +Q, or if you wanna DQ, just -Q. A quick update on the latest around the server issuer identification. That's right now in IETF last call, so good progress there. So getting closer. And today we'll talk about token exchange profile for enterprise, and Kelly will walk us through this, and that will conclude our interims for this time. And hopefully next time we'll meet in person in the IETF. We'll see how it goes. Any questions? Any comments about anything here? Okay. Let me stop sharing here, and I give Kelly a chance to. Here you go. It's Kelly. It's yours.
All right, thank you. Give me just 1 second
Yep.
here. I'm getting a note that I have to change my system preferences in order to share. So give me 1 second.
Yep.
All right, let's see if this will work now. I'm sorry, it's giving me an issue. So I may have to rejoin the meeting. Hang on 1 second. I apologize.
Okay, no worries. Take your time. While he's like Kelly is trying to resolve this, I posted the link again. Please go and add your name to that list. Okay. If you can do that.
Do we have a minute taker?
Oh no, I haven't. I forgot that. So anybody, can someone please take notes? Volunteers might be waiting.
This is Justin. I can take notes. I think I still speak MITRE.
Okay. Thanks, Justin. Appreciate that.
Thanks a lot, Justin.
Let's wait for Kelly. Do you still have problems? I can present the slides from my side if you have problems.
I believe I've gotten it. Thank you. I apologize again for the delay.
No worries.
All right, so let me.
Yeah, we can see your screen here.
Okay. All right, so you can see the beginning slide here.
Yeah, but I think we're seeing the second screen.
You're seeing the wrong thing, huh? Oh my goodness.
You're sharing the wrong screen. That's all.
Oh my goodness. I apologize.
Displays, that's probably the easiest thing to do.
All right.
There you
go. Practice to.
Yeah, it's
presentation skills among friends.
All right. So are you seeing anything now, or am I not displaying anymore?
You are displaying,
it
but
works.
Yeah.
Oh, but you can just see my screen, right?
Yes.
Yeah, you may want to go in full screen mode if that would be better.
All right. Let's see.
It's
slideshow. Yeah.
Yeah, slideshow.
Yeah, the first one. Play from the start. Yeah.
But you're seeing the wrong thing, right?
Yeah, but
I don't want to.
You just use use slideshow. That you switched and it worked initially. Yeah. Go.
So,
yes.
So yeah.
Is that good?
There you go. That's
No,
it.
there you go.
Sorry, I appreciate your patience. All
Yeah,
right,
no worries.
so today talking about token and identity chaining using OAuth Token Exchange. This is work that we've done at MITRE in support of enterprise environments. We have, well, let me just go to the next slide here. We have a couple. So do you see everything clearly? You don't see all these pop-ups that I have on my screen, right?
No, we don't see anything. That looks
All
good.
right, great. All right. So we, a few years ago, published a couple of profiles for identity bridging and federated authentication, enterprise mission tailored OAuth 2.0 and OIDC profiles. And so we have profiles that add additional requirements to those standards to improve security, improve interoperability in enterprise environments. Let's see, one of the main maybe assumptions that we're working with is that servers have PKI certs, MPE certs, and typically users have PKI certificates as well in this enterprise environment, although we're looking into other authentication methods. Currently, the PKI certs are distributed to users. All right, so here's the problem. If you've got an OAuth client who makes a request to a protected resource, a resource server PR1, but that protected resource needs to access a second protected resource, maybe a backend database, and this can continue on as many times as necessary until the data is produced. And so to answer the client's request, the PR1 needs to access a second PR2. And today we're going to look at a couple of cases depending upon the ICAM ecosystem. So there's a single ICAM ecosystem where all the protected resources belong to the same organization and trust the same authorization server. The second situation is where you've got at least two of the protected resources in different organizations, and the PRs trust different authorization servers. So the single ICAM ecosystem is fairly straightforward. The multiple one is more complicated, but the solution to both at a high level is that PR1 acts as an OAuth client and uses the token exchange protocol to get a second access token, which is good to use at PR2. Because the original access token is good for PR1, who needs to get a second access token, which is good for PR2, and so token exchange is the method that we go about doing this with. All right, so here's a diagram for the single ICAM ecosystem. So you see at the bottom, you've got a single authorization server, single runtime service down there, and all the protected resources trust that same authorization server. So the basic flow is that the client gets an access token from the authorization server and sends it to PR1. But PR1 doesn't have the data that the client needs, so PR1 performs token exchange with the authorization server to receive a new access token, which is good at PR2. And that token we require to contain the identities of the user, the client, and PR1 in various fields. PR2, if it has the data, it returns it. If not, it repeats the process, exchanges the token for one good at PR3, and so on until you finally get to the protected resource that has the data the client has requested. It validates the token and returns the data back down the chain to the client. So you see on the right, there are the claims that we require to be populated and how they are populated. We require the audience field to be the protected resource intended to be consuming the token. And then there's the ACT field, which contains essentially a history of all the tokens that have been exchanged previously. So you see that PR1 exchanges for a token that it uses at PR2, and PR2 exchanges that it uses at PR3. And so all the identities are contained in the final access token so that the final protected resource can verify privileges along the way to make sure that the data being returned is allowed to be viewed by everyone along the chain. So any questions on that before I go forward?
I don't see anybody in the queue there, so.
All right, thank you.
Yeah.
All right, so as I mentioned, if you've got a multiple ICAM ecosystem where you have different organizations with different authorization servers, it becomes more complex. We don't say anything about the user. The user can be in the same or different organizations as the first protected resource. It doesn't matter. All that does matter is that the user is able to authenticate to the first authorization server in organization B and receive a token. So it doesn't matter if it's in the organization B or in organization A. And I mentioned that users typically are issued PKI certs. That's not required. So it can be PKI, but a user can authenticate in any way that he or she is allowed to by the authorization server. All right, so the user and client get the first access token, which it presents to PR1. And so this isn't entirely accurate. This is a high-level view because there's a lot of details that get added when you really think about, for example, messages 3 and 4. How does PR1 exchange the first token for the second token? For example, who issues that token? I've got it here with AS1. Okay, so yeah, some terminology. AS1 is what I'm going to call the authorization server in PR1's organization, and AS2 is in PR2's organization, and so on. So this is the basic high-level flow, which looks very similar to the single ICAM ecosystem, except when you get into the details of how you go about exchanging the tokens for a new one. And we have 4 potential solutions that we're looking for feedback on, whether you think they're good ideas or not, whether you think these are either already implemented or likely to be implemented. I'm not up to speed right now on what token exchange implementations are out there, but this does obviously require that implementation in order to be able to do any of these 4 solutions. All right, so I'm just going to go through these relatively quickly here because I'm going to go into more detail on each in just a second, but I wanted to just sort of tell you what I'm going to tell you here. So all right, the first potential solution is that PR1, when it needs to access PR2, obtains a second access token using token exchange from its own authorization server AS1. All right, so that's PR1 just does token exchange with AS1 to get the second token. A second solution is that PR1 performs token exchange, but instead of getting the second token from its own authorization server, it gets the second access token through token exchange from the authorization server in PR2's organization, so from AS2. And all of these have pros and cons that we've identified. We haven't found any of these to be necessarily a lot of pros with no cons. There's pros and cons to every one of these. So we have 4 options, but we've mysteriously labeled them 1, 2, 3A, and 3B. But that's really because the way that these solutions evolved. We originally just had 1 and 2. And then after some conversations we had, we added 3A, which uses an assertion. So instead of doing a token exchange grant, it uses an assertion grant to get a new token. And then we thought about 3B, which also uses an assertion grant. So we thought, well, the last 2 options use assertions, and so why don't we call them 3A and 3B? but there are 4 options, right? It's just the way we've named them. Anyway, 3A, PR1, instead of requesting an access token in token exchange, it requests an assertion from its authorization server that it sends to the second authorization server, AS2, as part of an assertion grant to receive the second access token. And the 4th option is where, well, there's some magic that happens with AS1. So let me just get into that. It's the same issue. It's the same solution. PR1 gets an access token that it can use, but the way it obtains it is different. All right, so here's some details on solution 1. So as I said, the solution is that PR1 performs token exchange with its own authorization server AS1 to get the second token, which it then presents to PR2, who uses that to return the data. Now, the second token, which token 2 in the diagram, was generated by AS1. So PR2 may not have a way of validating this, and AS2 is going to have some special circumstance in order to be able to validate this token 2, because it was generated by a different authorization server at a different organization. So let's get to the pros and cons. All right, so the upside to this solution is that protected resources in one organization don't need to register with the authorization server of every other organization, right? Because PR1 performs token exchange with its own authorization server. It doesn't have to have a relationship with the other authorization servers. And so there's no need, because one of the requirements that we have in our OAuth 2.0 profile is that, everyone is registered ahead of time, right? So this is a good win right now, because, and this is listed as a pro, maybe you can guess, because it's going to be a con for another option later. But the cons for this option are that what I pointed out, PR2 needs to be able to trust access tokens issued by AS1. And so our solution to PR2 and AS2 being able to validate these tokens is that there's some sort of trust relationship between AS1 and AS2, where AS2 can verify access tokens by AS1, and we've suggested the use of token introspection. Now, this is not the way it was intended to be used. We know that. But if PR2 can perform token introspection with AS2, and AS2 has a special relationship with AS1 where it can validate it and verify its tokens, then this will work, right? But we do recognize that this is, as we've called it, off-label use of token introspection. All right, so I can't see the chat. Is anybody waiting to say anything, or can I go on?
No.
All right,
was
thank you.
Note here? That's in fact. Okay, there was a comment from Justin. So Justin, go ahead.
Yeah, just to note that that's not at all an off-label use of token introspection.
Oh, really? You think it's all right? I mean, there's nothing
cross-
wrong with it, right? It's
Yeah,
not
cross-
disallowed. It's just not what we thought the original intention was of token introspection.
Yeah, I mean, crossing security domains is perfectly reasonable, and that's one of the reasons that the authentication, the resource authentication requirement is in there. I do regret that it is written very, very loosely in the introspection spec itself. But yeah, we did not intend for it to only be used inside of single security domains. Crossing domains was a deliberate goal, and actually utilized in some of the early healthcare profiles that leveraged it. So
Very good. Thank you for that information. I feel better now because I was calling it off label, right? And so
okay. Brian.
Yes. Oh, I'm sorry. Go ahead.
Sorry. Sorry. Hold on, Brian. Kelly, did you want to say something? Hold on.
No. I didn't know there was. So I'm sorry. I can't see the chat, so I didn't know there was somebody else waiting to talk.
I will let
Go
you
ahead.
know. So Brian, go ahead.
I guess I can't speak to the original intention, but I think it would be expecting that to work by normal implementations of introspection would be unwise. So that, however Justin wants to phrase the original intent aside, that there's still potential problem here in expectation of actual implementations working this way. I don't think you would find that to be very common.
Ah, okay.
So the con remains. It's just maybe you could phrase it differently. I don't know, but I don't know any introspection ASs that will just verify other ASs tokens.
Oh no, it's if I'm understanding this, it's verifying its own token.
Nope.
So AS1
Right.
generates the token, and AS2 is trying to verify it.
Oh, AS2 is verifying the token?
Yes. So that's why there
I-
has to be some sort of special relationship between AS1 and AS2 for that to
Gotcha.
happen.
Okay, no, that is off label.
Okay.
My apologies. What I thought was happening was that PR2 was calling back to AS1 across the security boundary.
No, it's going to its own authorization
that would
server.
Right. Okay. So that I would expect to work. This I would not. So no, you are correct.
Ah.
This is in fact off label. My apologies. That was my misunderstanding of what was going on in this.
All right, no problem.
worries.
Thank you.
Okay. We have a few more in the queue here. Jeff.
Sure.
Yeah. Is this to imply that the user identification space between these multiple organizations kind of needs to be the same, so that like the subject follows from the user through this chain in a sensible manner? Okay.
Yeah. So watch out. I'm going to go back a couple of slides. Okay. So you see over on the right that box, right? So we use the ACT claim to keep track of everything that's happened so far. So we know everybody that's been involved in the transaction, the user, the first PR, the second PR, and the client, and so on, right?
Okay.
Does that answer your question?
Yeah, well, yes, but I guess to follow up on that, doesn't this sort of imply that there's already like a fairly strong pre-existing relationship between these organizations if they're sharing the same user identifier space?
So I think that, well, yes, and maybe we're assuming that the relationship exists so that this will make sense.
Okay, I mean, because I think that's I guess where I'm coming from is that since this relationship is already implied, this idea of needing to register the relationships between these multiple ASs and the PRs seems like it's already kind of a core requirement for this and the problem that you're trying to solve, I suppose. So that's all I had to say. Thank you.
All right.
Thanks, Jeff. Aaron. We can't hear you, Aaron. Aaron? Okay. He's having some issues, I guess. Okay, anybody else has any comments? Okay, so yeah, keep going then, Kelly, and we will see if Aaron can come back later.
Right. So I mentioned there's 4 options. Here's the second one. It's essentially the same, except this time PR1 performs token exchange with AS2. Right. So and everything else is the same. So it gets the second access token 2 that it presents to PR2, and everything else is the same. The only difference, instead of PR1 doing token exchange with AS1, it does it with AS2. All right. So the upside, the pros
Sorry,
of this.
Kelly.
Yeah. Go ahead.
Aaron, are you back?
Can you hear me?
Yes.
Great. I don't know what that
Right,
was
let's go
about.
back.
Sorry. So on the introspection question, my understanding about that was that one AS would be using the introspection endpoint of the other AS in order to make that work, which then does sound like like a reasonable use of it. Is that not the implication there?
Yeah, so the idea is, yes, that PR2 performs introspection with AS2, and AS2 is somehow able to validate tokens produced by AS1 to be able to validate, verify that information.
And that somehow could be another token introspection call, right?
That's possible. So that's we haven't defined that yet. It's beyond the scope of where we are at the moment.
I see. Okay. Okay.
All right. Thank you.
Yeah, keep going now.
All right. Thank you.
Clear.
All right. So option 2 is where PR1 gets does token exchange with AS2. And so the upside here is that PR2 only has to be able to validate tokens issued by its own authorization server, because PR1 has performed token exchange with AS2. AS2 generated the token. And so this is nothing special to PR2. It's used to receiving access tokens from its own authorization server. So there's no issue here, right? The downside is that now, it was a pro before, now it's a con. The protected resources in one organization have to register with the authorization server of every other organization, because we require clients to register, and so it's acting as an OAuth client and token exchange. And so so you basically have to know everywhere you're going to have to perform this token exchange, and make sure that all of your protected resources are registered in every other organization that it might need to access information. And then the other downside is that AS2 has to be able to trust, interpret, and verify tokens by. Oh no, that's not right. Okay, that's a mistake. I'm sorry. So that shouldn't be there, because here the token is being generated from AS2. So that's a typo. I apologize. Copy and paste error, I'm sure. All right. So the third option, 3A.
Kelly.
Now, yes,
hold
go
on.
ahead.
Brian, you have a question?
2 things. I think that is right.
Is it right?
But it is easy to get lost in the details of which things going where and who's validating who. But I think in the context of that one, that is a correct
All
statement.
right. Well, let me think about it again, because I know there was one place I meant to take something out, and I didn't know if I did or not. So let's see. AS2 has to be able to trust tokens issued by AS1. Oh, sure, because it has to do token exchange. Yes, I'm sorry. You're right.
And while I have the mic here, it's not in the slides, but in the document itself, there's kind of following along from these same issues of who trusts whose token and who issues it. There's some incorrect use of the access token URI for identifying the token. In general, the token exchange draft defines the access token URI as being an identifier for an access token either issued by or about to be issued by that particular AS itself. It's relative to the AS to whom you're talking about.
Okay.
Throughout the or at least in a few places, it's used in relation to access tokens that are issued across organizational boundaries. And it's kind of a small nit, but it's also sort of fundamental in the way, like, sorry, I'm having trouble articulating it, in like who's issuing and trusting who. And it's actually a pretty important distinction that when you're doing token exchange, that identifier means an access token issued by this particular authorization server. And so something else would need to be used to denote access tokens from another authorization server. And there's not currently a URI defined for that. So the profile, I think, would maybe need to create its own, and in turn with that might also need to, in the URI, indicate who the issuer of the token was to allow for the consuming entity to actually be able to process the token.
Okay. Yeah, thank you for that. I wasn't aware of that detail. All right. Yeah, I was taking a note on that. Thank you. Yeah.
Yep, it's definitely
Right.
text and token exchange that talks to that, although it's not super obvious. But when you get down to trying to run through these flows and like actually make it's an important distinction for these systems to be able to process things correctly.
Okay. Thank you. I appreciate that.
Yep.
All right.
Go on.
Anything else?
No.
Okay. Thank you. All right. So here we are. All right. The third option, 3A. So this time, when PR1 gets token 1, instead of performing token exchange with its authorization server to get a new access token, it does token exchange with its own access server, authorization server. But instead of requesting an access token, it requests an assertion. And so it's not done yet, right? Because it needs to use that assertion in an assertion grant to exchange the assertion for a new token, right? So it trades the first token for an assertion, and then it trades that assertion for token 2. But you can see that the trades, the exchanges are done with different authorization servers, right? So it applies to its own authorization server for the assertion, and then uses that assertion with the other authorization server AS2 to request the second token. All right, pros and cons. All right, so in this situation, since the assertion was used to exchange at AS2 for a new token, token 2, PR2 only receives access tokens issued by its own authorization server, and so there's no issues there. And this is just a note, really, that there's so we are familiar, and I think Brian, you pointed this out to us, that assertions are intended to be used across security domains. According, there's actually text in the standard for that. But again, so the assertion is generated by AS1, so AS2 needs to be able to trust that assertion in order to respond with token 2. AS1, AS2 need to be in agreement on the content of the assertions, because the details of the assertions are left up to the server, and so they here's more communication, right? There's a lot of AS1 and AS2 need to be able to communicate or have an agreement or have some sort of trust relationship. So here they have to agree on the content of the assertions so that the implementations will agree. And there's an additional step. Well, 2 steps, right? It's a back and forth between, when you exchange the assertion for token 2. And, depending upon how, we don't know, but there may be latency delays, right? Only in the sense that there are more steps taken, and so more steps take more time. Whether that's important, we don't know. All right, last one. So this is the most complex one, and it's similar to the previous one in that there's an assertion involved, but this time when PR1 gets token 1, it performs a token exchange. But it requests a token. So in the previous example, when PR1 made the token exchange request with its own authorization server AS1, it requested an assertion be returned that it then used to get token 2. Well, this time, there has to be some sort of information in AS1, right? It has to be configured so that when it receives a token exchange request from a protected resource in its own organization, such that it wants to be able to access a protected resource outside its organization. It then knows. So you can see there's a difference in the order of the execution of the messages here. So when PR1 requests a token, the next thing that happens is that its authorization server AS1 generates an assertion. Is that me making that noise?
Yes.
Yes,
All right.
it looks like you're getting a call. You may want to shut down Teams.
Thank you. That's not good. All right, it went away. Sorry, I apologize.
No worries, keep going.
All right. So AS1 gets the request from PR1 for a token. It knows that it needs to generate an assertion that it sends to AS2 in an assertion grant in exchange for token 2. So AS1 does the dirty work. It gets token 2 for PR1 and then returns that token as part of the token exchange request for an access token. So it returns the token that was generated by AS2 back to PR1, who then presents it to PR2. So like I said, I know this is complex, but it's interesting, right? So pros. PR1 doesn't need to be registered with AS2 because it performs token exchange at its own authorization server. PR2 only receives access tokens issued by its own authorization server because of the way it's done. That AS1 generates the assertion that it receives token 2 from AS2, so PR2 still is, there's nothing special going on at PR2. And again, there's this text in the standard for assertions that says it's intended to be used across security domains. All right, so the cons, usually have some sort of, necessary trust relationship. And so here, AS2 has to trust assertions generated by AS1 in order to respond to the assertion grant for token 2. And again, AS1 and AS2 need to agree on the contents of the assertions, and same issue with latency. All right, so those are the 4 options. And I want to go to the next slide, so that's the end of my of what I wanted to say. I'm just coming back to this slide because I'm hoping to get some feedback in terms of whether you think one solution is better than another, more practical in terms of implementations and things. So let me open up the floor to anybody who has any comments, questions, and see what's going on.
Okay, anybody has any comments? Brian?
Me again. One comment on 3B. I've always liked that model, but it never seems to work out as well as it looks on paper. But if I'm remembering correctly, all these tokens are also supposed to be bound to the client certificate of whoever's making the call, right?
Yes, because we do require mutually authenticated TLS with certificates, yes, for the client.
It gets really problematic in that you're trying to issue a token for the protected resource to use, but it's being done through the context of the AS calling it, who doesn't have that certificate. So getting the access token issued by AS2 correctly bound to the certificate of, I think, PR1 is somewhere between impossible to like really funky. And so in the greater scheme of how all these things work, I'm not sure 3B is even a viable option without a lot more work about passing along the certificate information, which probably then just makes it not worth pursuing.
Okay.
Does that make sense?
Yeah. So I mean, we realize that we're dealing with sort of a certain particular environment in mind, right? And that's not necessarily the model that's common, right? And so we're trying to find some happy medium where we've got this special circumstance, but we want we don't want to break anything. We don't want to necessarily force something like what you're saying with the protected resources acting as a client with certificates, right? So if that's not even feasible given the current day implementations of things, then this is exactly the feedback we're looking for. If something is just not feasible, we'll take it off, right?
I guess in this case I was just speaking to the logistics of who holds the key for what certificate at what point, and that in that 3B it just isn't really feasible. Like, it doesn't make sense because the caller is different from the entity holding the certificate. So it's not really possible to correctly bind the token in that case, and less about like current implementations or other things. It's more just a logistical problem of the way that the flow goes.
Oh, okay. Yeah, I get it.
Can you, yeah, if you, I don't know if you could pop back to the diagram.
Yeah, sure.
In this
This
case,
one.
yeah. So in step 4 here, you've got, one service calling the other, but ultimately you want the token that's going to be issued as a result that'll be used in 6 to be bound to PR1 certificate. So it's at the time of issuance, the AS2 just has no context of who that is and can't bind it without additional information flowing through, all of which would be non-standard or off-label and maybe problematic to support.
Yeah, so we do assume that in our enterprise environment that all servers have MPE certificates, right? But I understand that that's not enough, right? So in terms of implementations,
More so that even if everybody does have a certificate, the certificates are exchanged and established on the TLS connection between the two entities. So, but you want the certificate bound for the token for PR1 when the AS1 is going to be the one making the call here. So it's like there's a mismatch. And
I see. I understand what you're saying. Yeah.
Yeah. Okay.
Thank you. Yeah. I hadn't thought of that before, so I appreciate that.
Okay. Warren.
I feel like I have a similar question, but it applies to the other cases. I'm not sure I fully understand what the sort of use case is where the resource server, the protected resource server at the end here is going to be verifying, and how it's actually going to be verifying the identity that's coming in. Like, is the expectation that the data with the subs are going to go out and verify each of the individual layers that are in here against each of the ASs? Otherwise, I mean, I feel the answer is no. In which case, isn't it just fundamentally only trusting the last authorization server? In which case, what's even the point of stacking these authorizations on top of each other? You're pretty much just collecting a bunch of tokens, one from the original user, one from PR1, one from PR2. I mean, that can just be a simple list, right?
Yeah, so we want to make sure that we know, for each token, the client and the intended recipient, right? The protected resource, which is the intended consumer of the token, right? So those get populated in each token and then transferred along. They get chained along through the ACT claim. I don't know if that addresses your concern.
Are you saying that the intended, but it's only the intermediary intended target, but it didn't seem like from your example that the protected resource 1, 2, N are actually being saved in that stack, but you're actually saying that there are claims that aren't there that would normally be in your process.
Yeah, so I mean, sorry, I'm gonna go back a few, to that same slide that has, the ACT claim, right. So we have the entire, audit log of everyone who's participated in the transaction so far.
But it doesn't contain the signature of those. So there's nothing that stops the A3 from lying about going through PR2 and PR1 before sending along that information, or even if that the original user was correct.
So our tokens are signed and can be validated using the signature.
Right, but how many signatures do you have on this total structure?
Well, every token is signed, right?
Well, right, but it's signed by the A3, right?
Well, so each token is signed by its respective. Okay, so I've gone too far.
So just looking at,
yeah. Go ahead.
You're in the last exchange, the last time. You're organization C hitting protected resource 3, which is going to be the end of the chain.
Yep.
What signature is on that token?
So it's the last token, token 2, that was generated and signed by AS1.
No, after that, right? There's another token here, right? In this situation, I would have a new token signed by AS2, right?
Token 2 in this particular, okay, so this is option 1. All right, so I mean, so in this particular example, AS1 generates token 2, but PR2 consumes it, right? So there's different examples, and I think the answer may be different for each example. Let me think about that for a second.
So even in this example,
No.
what starts AS? You know, PR2 in this case, in this first option is trusting AS1. What requires AS1 to actually have sent that it is the user? Like, why it could just be malicious and lie about that. Say it was a different user when that token is being sent along because the signature of that token is no longer present in the at PR2. Only the signature from AS1, not the signature.
Yeah, so I think Justin has a comment that might help. Justin?
Yeah, so I think I see where some things are getting potentially tangled here. To answer Warren, and I've already proven myself to not accurately interpret these diagrams and slides once on this call, so bear that in mind. But my understanding here is that, yes, the token is signed by the last AS in the chain, whatever that is. In option 1, it's AS1. In option 2, it's AS2. It's whoever issues the token signs the token, and that AS is allowed to lie about the token because that AS is allowed to produce whatever tokens that it wants to. And that's a fundamental trust relationship of the AS to the RS in OAuth, and that is not changed by any of these proposals, which is why, at least to my understanding, the pros and cons of which AS a given PR needs to trust and know about is an important consideration in the trade-off space, because trusting an AS from outside of your organization to be able to do things and issue tokens for you is a very high lift for a lot of services. Hopefully that was helpful in untangling what I think was being asked and presented here. And if I got anything wrong, I apologize.
Oh, you got it. Thank you, Justin.
You're right on my side. Thank you. You resolved it.
Okay. Beth? Somebody? Beth?
Yeah.
So
we designed this for a very specific environment. And if you notice, there is also an attribute sharing infrastructure connecting all of this underlying the ASs. So there is a very strong trust infrastructure beneath all of this. It does not work in every environment. It does work in our mission environment.
Okay, thank you, Beth. Anybody has any other comments, questions? Okay. I see no other nobody in the queue here. So
Well, thank you.
Thank you, Kelly. Hold on. So I wanna get a feeling from this group is are people interested in solving this problem at the OAuth work group? Is there interest in kind of addressing that? So if you are, I'm gonna ask that question, and I'm trying to get feedback in the chat here. Obviously, we'll take it to the mailing list after that, but just wanna get a feeling of what people think here. Is there interest? If you are interested in this topic being discussed and addressed in the OAuth work group, please +1 in the chat. Dimitri.
My question actually is relevant to other token binding mechanisms, not about the last questions that you voiced. Okay, I'll ask it.
Sure.
Yes.
So we have mentioned MTLS as a mechanism for binding tokens to the user agents. Might any other mechanism defined, like Depop, be relevant here?
So, Depop, we're still, waiting on to see how it turns out. We like the server nonce, right? That alleviates a lot of the issues that we had with it, without it, and so we like that, even though it's still a may as far as we can tell in the document. And I think there is one other. There's another token binding mechanism, right? There's a draft out about using an asymmetric key pair, right? So that's another option. Does that properly address your question, comment?
Yeah, okay, thank you.
Yeah, sure.
Okay, so let me go back to ask my question again. If you are in favor of working on this problem statement or problem and issues that was presented today at the OAuth work group, please +1 in the chat.
I don't have access, but I'll put a +1.
I'm expecting you to have a +1.
I know. I was being silly.
I'm asking the rest of the group here. Say more, Justin. You wanna say something? Go ahead.
Yeah. So so I actually did a +0. And because I don't think that this is I don't think that this would be a harmful or detracting topic here in the working group. I think it could build on a lot of things that we've done in the past. But some of the things that Beth brought up a minute ago are that there are a lot of sort of environmental assumptions with something like this about the trust relationships that makes me question whether or not that this approach is generalizable to the level that actually makes it have utility for a working group draft. That's not to say that it's not. It's just that I'm not convinced that out of the box that it was. And I say this as somebody who back when I proposed my token chaining draft while I was still at MITRE was to solve very similar problems. That was, I think, 10 years ago. I'm looking up the draft date right now. It was a very long time ago. And the ideas in there were eventually subsumed by the larger token exchange draft. And it was 2012, so we're on the 9-year anniversary now. It's not at all surprising that that this is still a topic of interest, especially coming from communities where you can control a trust and sharing infrastructure and have these back channels of communication between trusted components in order to facilitate this. What I'm wondering, though, is how much of that also needs to be standardized, because I don't think it would be beneficial to the community to have a spec that relies on those questions being answered somehow or relies on those trust relationships without being extraordinarily specific about what those relationships need to be. Right.
Okay.
So when we took the original token chaining proposal to the working group, the original draft that I wrote was literally just the I have an access token, I get an access token portion. It was none of the rest of the infrastructure that that we were building out in similar spaces back then. And so I'm mostly questioning what the right cut point here is, and if there is one.
Warren.
So I guess for me, it would be conditional on something, because I do see with the attribute sharing infrastructure and the trust relationships being there almost as like a single box around all the ASs. And if we treat that as a single authorization server, and these as individual clients, protected resources, but potentially clients of that authorization server, then it does feel very similar to Depop, but only in a way we could stack Depop on top of each other for subsequent calls, but in the context of a single authorization server. So for me, that would be a +1, but as long as there's no language about how to handle across a security boundary, a security domain.
Okay. Okay, thanks, Warren. Anybody else has any comments, questions? Beth?
So there are actually two different proposals here. There's the one that's the single security domain or ecosystem, and one that's the multi security system. And they may have blurred together because Kelly presented very quickly. From our perspective, we are very interested in making things as standardized as possible, hence we're taking it to this working group and taking it forward to get comments from as many people as we can. Yes, we understand we have a very specialized environment, but we'd like, that's why we're asking about, could commercial products do this? We don't want specialized products. We would like to use commercial products. We would like to have our ideas incorporated into commercial products, even though we do understand we have specialized environment. So just offering that up.
Okay. Like we have 1 minute here. Anybody else has any comments, questions? Last minute here. Okay, I didn't see too much support for this at this stage, but maybe Kelly and Beth, you got good enough feedback to maybe work on those and try to address those, and maybe try again in the future after you address those concerns that you heard from the team, and maybe you can think about this again and consider it in the future. Is that reasonable from here?
Yes, that sounds good, and we certainly appreciate the feedback we got today, and we'll make good use of it. Thank you.
Okay, awesome. Thank you all very much for your time, and that's it. We're done with the interims for now. See you guys.
Thank you.
Bye.
Thank you, guys.